Do you want to have any questions for the homework? On page 61, number 1127.
Haven't we already done
11, 27, and 56. Yes.
Do you require the further changes?
What's that?
Do you want to
For what do you mean? What exactly do you mean?
like we changed it from the text to
Where was that? What problem was that? No. Which is easy though, it's just foiling. It's basic. I mean, you should. It's fun. I mean, it's simple foiling. But not for the test. No, not for the test. But you should know that. Okay. All right. So let's look at. I think we're looking at this problem here. And we left off on this, yeah. Okay. All right. All right, so this is definitely something that you need to know for the test. So, this one in particular, it was already fairly straightforward. It was you had x's that already matched, their coefficients already matched. But if you had nothing that matched, you would have to pick one and multiply the equation by some constant, non-zero constant, to get things to match. Right? They didn't match already. So, look at. Doesn't matter which two you pull over for this particular one. All the x's look the same. So let's go with, we have 2p plus x plus y equals 14. Did anyone finish this problem, by the way? No. No? Okay. Okay, so we'll see what we got here. Let's pull this guy over. And I have p plus x plus 3y is equal to 15. So, take these two, and if I'm going to subtract all the components, I need to be careful with what parentheses around it. Like in what? The homework that was due on Wednesday?
Well, no, you gave us the under assignment, so we can do today.
Was the finish the
If you see one period 6, do one for 22nd.
Oh, okay. Yeah, that was the one where I had the written for. Oh, because it was assigned on Wednesday. Yeah, okay. I asked if anyone had any questions on that. Do you have any questions on that homework?
Nope.
Okay. And I want to focus more time on preparing you for the test. Okay. We'll look at that after this. Remind me after this problem, we'll look at it. All right. So for here, let's go ahead and keep moving forward here. So we have the x's would go away, so we're just left with p minus 2y equals negative 1. Now we have that guy developed, so now we have to use, I know I have to use this guy. I have to do something with that guy because I used the first two. Okay? I developed some equation, some two-variable equation. Now I have to do something with the third. Okay? And it doesn't matter whether I do something with the third and the first or the third and the second, but I have to do something with the third. So let's go ahead and continue forward. And let's go ahead and line up so that doesn't matter which one you pick. So let's pick the second one. So P plus X plus 3Y is equal to 15. And notice that the X's, they match exactly. So I'm going to subtract. I'm going to subtract this entire guy from this guy. In doing so, I will have 2P minus Y is equal to 7. Now, what was key about this was that because I eliminated my X the first time I did this, when I chose the first two equations, I needed to eliminate the same variable. So that's a key point. So eliminate the same variable. Because I want a system of just two variables. This is key here. Okay, so we went ahead and did that. We eliminated the x's. So now we have these two. Anyone have any questions at all? Because these two will be tested on. So anyone get confused? Like, when do I do this? When do I do that? About where we are now? Yes.
So what you do is you find the first two quantities. After you solve it, you pick a different one. After you solve it, get your answer,
Yeah.
you pick a different.
Yeah, it doesn't matter which two you pick. But because I use these first two, and I developed an equation out of that, I have to now use something like third.
All right, and then you gonna solve. So you gonna put those together like that. You gonna put the answer together.
I'm going to eliminate the x's. Is that what you're saying?
She's asking if you put both the answers that you got for the two different equations, are you putting them together?
Oh, these two here? Yeah, so that's where we are now. So now we have this developed, so now we're going to do something with these two. Okay, so now it's just, notice they no longer have an x, right? That's why we have to eliminate the same variable. You don't want to eliminate the x and then pick the third and one of the others and then end up eliminating the y. That would defeat the purpose. It wouldn't get you where you need to go. So now we're here, and okay, so I'm going to, I look at this, and it looks like that they don't quite match up, and this is what I'm talking about. And this could have been the same scenario that we had at the very beginning. We just happen to have a system, this particular problem, where all three of the x's happen to have the same coefficients. But now I have a situation where, as it's written, I can't just eliminate the y's, or I cannot just eliminate the p's. I have to multiply one of the equations by some non-zero constant, some regular number, so that things match up or are the exact opposite, right? If they match up, subtraction. If they're the exact opposite, add. So look at this, and you say -2. So multiply, let's say this one by -2, or this one. What's that? Yeah, for this one it doesn't really matter. If I multiply this guy by -2, I'll have the y's go away. If I multiply this guy by -2, the p's go away. Now that's not always even the case, but this particular one, it happens to be like that. So let's go ahead and do that. Let's take this guy, and we're going to multiply it by -2. And what would we have? So now this is where you got to be careful. Each term is being multiplied. Yep, so you have -4p plus 2y, be careful.
Oh, that's already negative. Yeah. Oh, equals negative 14.
Equals -14. And this guy I can just bring over as he's written. Now I would have p minus 2y is equal to -1. And now you notice that the y's would cancel. So now you just have what's, now I'm adding, right? This is going to be, this is addition, right? I don't have to put parentheses because it's addition. So then -4p plus p would be at -3p. And then this equals -14 plus -1 is -15. So just be very careful.
If they have the same sign, with the addition standard or something. Negative, right?
Where we are now?
I'm saying with negative, that's the same sign, addition.
Yeah, so like negative 14 plus negative 1, I think of it as like I'm starting negative 14, and am I jumping further than the negatives or am I jumping towards the positives? Because they're the same sign, you can think of it as, okay, I'm going in the same direction. So yeah, you can ignore the signs, add them together, and stick the sign in front. Yeah. And then last step, divide each side by negative 3. So P would be equal to positive 5. Okay, so now you've reached this point. Now you can plug this into either one of these. Right? And it shouldn't matter which one. Okay? In fact, if you have different values for this one and that one, then you know you did something wrong. It should work for both. So if I plug in 5 for P, I got 5 minus 2y equals negative 1. And solving for y, what would you get? 3. Negative 2y would be equal to negative 6. Yeah, divide by negative 2, 3. Okay. If I plugged it, so I'm just seeing if I plugged it into here versus plugging it into there. Doesn't matter which. If I plug into that one, I should get the same value for y. 10 minus y equals 7. Yeah, y would definitely be 3. So I plug it in here, I'm going to get y equals 3. And then once you have, now you reach this point, now you just plug it into any one of the originals, the original equations. And again, as the scenario was here, same applies here in the sense that it shouldn't matter which one you plug it into. You should get the same value for x no matter which one you plug it into. So I'm going to shrink this down just a little bit more so I can fit this all. So it's this, I don't know, the first one is fine. 2p plus x plus y equals 14. Oh, you thought x equals 1, okay. So 2, let's see, 2 times 5 plus x plus 3 is equal to 14. Let's see if this is true. 10 plus, or let's see what x is, all right. 10 plus x plus 3 equals 14. X plus 13 equals 14. Subtracting 13 on each side, x would equal 1. Good job. So the answers, they could be right. I mean, they're definitely whole numbers. It would be like a red flag if I had fractional values, right? A fraction of a salad, or a fraction of, I think it was liters of soda or whatever it was, and a fraction of a pizza. That would be an issue probably. But you're really right when you can plug all 3 of these into each of the originals and it makes it a true statement. Any questions about this? Okay. You may not be given one where all the x's look exactly the same. In case that happens, just remember, like you did for here when you multiply this guy by negative 2, you can apply that principle in the very beginning to get things to match. And then this is the key here. Eliminate the same variable. After I eliminated the x here, I needed to eliminate the x there. Okay? There's this problem. Let's look at if we have time. Oh, you wanted to see number 27, yes.
Yeah.
By the way, go ahead and copy this down now. This is going to be the homework today. Page. Excuse me? Did you have a question or comment? You just want to word it out.
Why is there so much homework?
Why is there so much homework?
Yeah. We have homework every day.
Oh, what?
The reason, well, that's a good reason. The reason one is it's school. I don't know if we have so much homework. 2 problems.
We have homework every day.
But if I earned 1 penny a day every day for 30 days, I'd have 30 cents. So I'm not sure what you mean by so much. I'm not about the quantity of homework. I'm more about the quality of your work, so that's why I'm only assigning 2 problems as opposed to 6, 7, or 8 problems.
Do I take this over a full page from the
All right? And another reason is that you need to do problems to do well in math. You can't just watch someone do it. All right, and we were looking at number 27. Mary?
Yes?
Number 27?
Yeah. On page, we use like 63. 56.
No, it's not the homework.
The directions for this say to graph the function, label the vertex, and axis of symmetry. Did anyone get this one?
Yes.
I'm gonna say, yeah. How'd you do this? How'd you graph this? Where'd you start? Where did you start? What point was it? The vertex. Yeah, find the vertex. Okay. So we need to really establish that. So the vertex. Yeah. So the axis of symmetry, or the x coordinate of the vertex, is the formula is, in this you have to know negative b over 2a.
Oh, okay.
Right. That being said, x would equal. Now this is for standard form. This is standard form. This is ax squared plus bx plus c. So negative b over 2a. So negative 3 over 2 times negative 1.5.
Yeah.
So negative 3 over negative 3. Yeah, very good. So I know that I'm going to have this situation going on here where I have the axis of symmetry is x equals 1. And we know that the axis of symmetry is going to run through the vertex, so I know that the x-coordinate on my vertex is 1. How do I find the y-coordinate on my vertex if I know the x-coordinate?
You make a chart.
Plug it in. Yeah, plug it in. Yeah. So this is how you find the y-coordinate of any point if you knew the x-coordinate. So I say, let's go ahead and do the chart. So we have our XY chart. So when x is 1, let's see what we get here. 1 squared. This is, you gotta be careful too. The 1 squared. Negative 1.5 plus 3 is positive 1.5 plus 2 is positive 3.5. Okay. So the vertex should be 1, 3.5. And then let's pick some points just to the right and left. So 2 and 0. So it would be 2, so say 2 squared 4. Negative 1.5 of 4 is negative 6. right? Negative 1.5 times 4, negative 6. Negative 6 plus, negative 6 plus 6 is 0, plus 2 is 2. Make sure you're getting this. What's that? Well, this is one of them. You wanted to see another one? Which one did you want to see? 33. From another day.
I'll come up with 921.
Oh, I'm so sorry. I was like, what do you? Okay, yeah, that's okay. I didn't know what you were talking about. I'm like, where did you see from the last assignment? Okay. So let's finish this one. So we only have till it's tapped. So we only have till 12:35. So let's try to hurry up here. So 2 so 0 we expect to also be 2 and with 0 plus 0 plus 2. Make sure you guys are getting this. You know, you have to have this down, right? 2 squared is 4. Negative 6 plus 6 is 0 plus 2 is 2. Like 2 2. You plug in. Be careful with your work. So we have 2 2 and 0 2. Right? And then now let's look at just to the right of those points. Sorry, pause at 3.
I got negative 3.5.
For what?
3.
For 3? Let's see. 9 times negative 1.5. This is where I probably it's safer to use a calculator.
Work it.
13.5, negative 13.5. So negative 13.5 plus 9. Negative 4.5 plus 2 is negative 2.5. Is that what you guys got? And then one more to the left of it would be at negative 1. We'd expect to have the same output of negative 2.5. Yeah. 1, 2, 3, negative 2.5, and then negative 1, negative 1, 2.5. And we go ahead and just simply graph. So again, the directions for this problem, they were to graph, label the vertex, and axis of symmetry. The vertex was 1, 3.5, and the axis of symmetry was this guy. Alright. Any questions about this? So you have to have this memorized. Yeah. Alright. Everyone's going to do well on that?
Just to go,
No one's asking questions yet?
you come up with the student date or
It'll be sometime next week, probably Tuesday.
When's the college?
Yeah, we're going to go to college tomorrow night. Alright, so let's understand this. I think this is seen by 2 weeks. Alright, so we have something like this. See, this will be on your test. So you'll be given, so this is going to answer our question today. We try to answer is, how do we write an equation from the transformation described? Translate it 2 units left, 4 down, and a vertical shrink by a factor of 2/3, reflecting the x-axis, and this is from the parent function. Okay? When we are doing these transformations, okay, we want to start off with vertex form, which is this here, which you need to have memorized. And we have the parent function is just the basic guy, y equals x squared.
We have to have that memorized, that's not what we have like a reference sheet.
Correct.
That's kind of wrong. I don't even know, I can't remember. You said it was a lot.
Yes, so definitely have this down.
You remember that?
What's that?
You remember that?
I've written it down many times. And many times.
Oh,
I guess. I have to, I'm taking notes, so. I mean, are you writing, did you write down your notes?
no, that's why
Okay, so I'm gonna have to do it. So let's talk about this. Actually, I might be able to fit it on here. I might be able to put it on here, so you might be good. So translated, 2 units left, 4 down, and a vertical shrink by a factor of 2/3 reflected in the x-axis from, of course, it's from the parent function. So let's see if we can write this guy. So y equals, okay, so A, what does A deal with? Reflection? Okay. If something is reflected in the x-axis from the parent function, what does that tell us about it?
Negative.
Negative. Okay, so he's negative. All right. And then the other thing that we know about A as well, what else does it tell us? Yeah, vertical stretch and compression. Is this guy being stretched or compressed?
That's vertical shrink, so, right?
Yeah, it says in a vertical shrink by a factor of 2/3. So
Compressed?
A would be, yeah, what's called compression, yeah. So A would be negative 2/3. Right? As far as the shrinking or the stretching, that's just the absolute value of it. And then whether it's positive or negative, that has to do with whether it's reflected in the x-axis or not. And then we have the next part, minus. What would H be? What does H deal with? Do you remember? What does it deal with? What does H deal with? What do we call that?
Is that
The horizontal translations. Horizontal translations, so whether it's going shifting left or right. So whether it's shifting left or right. And is it doing that?
Yeah.
Yeah. It's doing what?
Translating
To the left. So what would H be?
negative.
Negative 2. Good. And then this is squared. That part never changes. And then now the K.
It's negative, negative 4.
It'd be negative 4 because it's going 4 down. So it's negative 4. So this is what you have to know on your test. So if you're not understanding, then please ask now. This is also what you need to understand for your homework. So.
you don't have like class will give you the notes, so I'm not looking.
No, this will not be an open book test. No. And so now we just clean this up.
If y'all know that you messed up, you just can't remember the. So if you can't remember the goals you messed up.
Yeah, you definitely need to have this down. Yeah, you need to have this down. Do you know the quadratic formula by any chance?
Yes.
No. Okay. So y equals. I ask you that because it's a lot more complicated. It's a little bit more complicated than that, and it's just as fundamental.
I don't know the first one. They have no is the Pythagorean
Yeah. What does that say?
a squared plus b squared equals c
And what is that about?
squared.
The legs and the hypotenuse. That's a good one to have.
Is that like a triangle?
Yeah, it's a right. It's a right side.
Yeah, that's fine.
All right. So that would be the formula that we're looking for. Translated 2 units left, 4 down, and a vertical shrink by a factor of 2/3. Reflect in the x-axis. So again, the reflection, that makes it negative, the A. The shrink, it's going to say vertical shrink or stretching, whatever the number is, that's what this is. Right? And again, whether it's positive or negative, that's just determined by whether it's reflected or not. The horizontal translations determined by the, that's what we fill in for H, and then the vertical translations up and down with reflected. And that's all you have to know.
translations left and right, up and down, vertical shrinking or stretching. We also use the word compression. Compression, shrinking mean the same thing. And then reflection. Yes.
Can you go back to the homework?
What's that?
Oh, what the assignment is? Yep, here's the assignment.
Let's make sure we have it written down.
All right. All right.
So let's try one more here. Let's go ahead and make this our exit ticket. Okay. So go ahead and do this on a separate sheet of paper. It doesn't have to be a huge sheet. But go ahead and attempt this one here. From the parent function, translated 2.5 down, reflected over the x-axis, and vertical stretch by a factor of 3.